Good morning. My name is Bruce Payette. I work at Microsoft. I've been there for about 12 years. So this is the title of the talk, as I had to send it in because we hadn't actually announced what we were doing. And I thank Chris for being interested enough to actually accept it without really me saying anything about what I was going to talk about. So this is the actual title, right? So in Windows Server 8.1, sorry, Windows 8.1, Windows Server 2012 R2, our naming is intriguing. So we're going to be introducing some desired state configuration management features built into Windows in all SKUs. So a little bit about me. I've been doing shell and utilities for a very, very long time, originally at a company called MKS, and then Software Systems that got acquired by Microsoft. I ported the Unix shell and utilities to a ludicrously large number of very strange systems. When I joined Microsoft, I was one of the founding members of the PowerShell team and co-designed the language with a fine gentleman named Jim Truer, who used to work for the Unix labs or whatever, something like that. Anyway, I'm the principal architect for PowerShell DSC, which is something that we've been working on for a little less than a year. Oh, and I wrote a book. I don't know why I'm supposed to say that, but apparently I am. My publisher appreciates it. So here's to summarize what we're going to go over. So Microsoft is supporting desired state configuration management as a first-class experience in Windows. It is DSC as infrastructure. So we will be providing an out-of-the-box experience, but we're an operating system group. We're not a product group in the sense of Puppet or Chef. And so one of our goals is to allow people to build on top of this infrastructure. Did anybody see the talk at TechEd where this stuff was officially announced last week? No. Okay. We had some folks from OpsCode come up and do a little demo of integration with Chef, and I have a video that they've kindly provided to show you guys. So our goal is to make Windows easier to manage in heterogeneous environments and at scale. So in cloud scenarios, our cloud, Azure, or Rackspace, or VMware, anybody who's running Windows, we want to make it easier for them to run Windows Server, regardless of their environment. So the overall agenda, I want to introduce the new technologies we're talking about, go a little bit into how we're thinking about how all this stuff should work, a little bit of demonstration because Microsoft always does demonstrations. I want to run this little video from OpsCode, and then I'm really hoping that people will have some questions. So here's the history, right? Windows was Windows focused on button pressing and things like that to do their management. Doesn't make for automation. It's okay for one server. If you have to go to more than one server, you're in trouble. We didn't have good tools. The other thing is, of course, if you're building a GUI, you want to have APIs to talk to because it's easier to talk to APIs than it is to talk to unstructured text. So we have lots of APIs. We created something called Windows Management Infrastructure, which was later standardized, and I'll talk about that a lot, for doing management. But it was pretty much a programmer's game. It wasn't really very manageable. A gentleman named Jeffrey Snover joined Microsoft from IBM, where he worked with Tivoli, and decided to look at fixing this. And out of that grew PowerShell. And also a lot of investments in the standardized management technologies, SIM and WSMan in particular. But even so, it's always been an imperative focus. You write imperative scripts, and we know how well all of those things work at scale. So the other thing is that one of the things about Linux, Unix that makes it so much easier to manage is it's very much document-oriented. If I can drop a file on a machine, then I can configure my web server or my mail server or whatever. And so by the very nature of the file system, it's pretty much transacted. We don't do that at Windows. You poke a lot of things. We're trying to fix that and introduce kind of a document model. The other thing that we can do, because we are Windows, is that we can try and enforce some common conventions across all of Windows. So this is one of the things that we did with PowerShell. There's what's called the common engineering criteria, where every group in Windows Server has to provide a way to manage their products through PowerShell, or through WMI and then through PowerShell. So we would be looking at doing the same sort of thing with our desired state stuff. Are people familiar with PowerShell? Has anybody used PowerShell, heard of PowerShell? A couple of people, okay. So very brief overview. PowerShell is an object-based shell and scripting language. The syntax is based on C#, which is based on C, which is what everybody likes. It is a strongly typed language, late bound. One thing that's a little bit different than something like Perl or Python, we very aggressively type convert to make it more shell friendly. And so at times I describe it as being promiscuously typed. It has all the things that you'd expect. It supports functions and scripts and modules. We have an adaptive type system to give you a consistent experience across all of the junk that we have. .NET, since this thing is written in .NET. We also give you an object view of XML, of SIM, of Active Directories objects, of database objects. And there's an extension mechanism where you can make random junk look like structured objects. It has built-in remote execution capabilities for running lambdas on a remote machine with fan-out and throttling and all that kind of junk. In PowerShell v3, we also introduced support for orchestration. Lovely word, that. Where orchestration means workflow. And so we have built-in support for workflow execution and workflow semantics in PowerShell. And the System Center Orchestration Manager v2 leverages some of this stuff. So it even has orchestrator in the title. Short examples. So if I want to get the directory listing, I type ls. This is an alias for a command, but we thought, I'm a Unix guy by trade, so I type ls habitually. But we also support dir. So if we look at the first line just lists basic directories. The second line does a recursive directory through a file system, filtering for files that end with .cs. It greps through those files and then extracts all the public classes. I have an alias for grep. We didn't ship one for grep because it hid other people's executables, and they got mad at us. We had to take it out. We do have aliases for a lot of the Unix commands. And then basic function syntax. So Fibonacci sequence. You'll notice there's no return statements. This is a shell language. So every statement that returns a value is emitted to the output stream. So is the return value. Supports recursion. We have much more complex parameter binding, very complex. So in this particular example, this contains a parameter declaration in one line of actual code, which says, so the $list parameter is a mandatory parameter. It's a type array of integers, and that array must be between the length 2 and 10. So we have this sort of attribution model to do a strong contract on our parameters. So that's PowerShell. Our goals with what we're doing in Windows 8.1, Windows Blue, whatever. Can't keep up, man. Okay. So we want to support the DevOps mantra of configuration is software. And I think Mark made some comment about configuration is knowledge, but then so software, I think the really important point about the statement configuration is software is that it's managed, right? It's written down, it's recorded, it's version controlled, it's change controlled. When you release a new release of software, you release a new release of the configuration components for that. So it's really introducing this discipline. The idea of having somebody run around and push buttons on 100 machines is appalling. Although interestingly, I was in Indonesia around Christmas time and talking to a fellow. And because labor is so cheap in Indonesia, they actually consider that it is better to have 100 people run out and configure their data center than it is to actually write a script, because it's like almost free. And they think that it's more reliable, but whatever. I think it's just a unique example of economies of scale working in an unexpected way. Something that's very important is we want, so we woke up and we kind of realized that there's other operating systems out there, and that interoperation is a fact of life. And so we want to work well in a heterogeneous environment. By preference, we want to use existing open standards. So I've been involved with POSIX. I've seen what happens when you try to do innovation by standardization. The results are not pretty. So we need to work with other things. We also need to work with what exists. And so there's been a couple of attempts at Microsoft to do this before, and it failed miserably because it said throw everything away and do it this new way. We want it to be lightweight. It's going to be there by default, so there's no install. And it needs to be very efficient. So let's take a look at the overall architecture, or our overall model, I suppose. You start by authoring your configuration. You can author your configuration in anything that understands how to produce our intermediate representation of configuration. For this release, our language is going to be a variation on PowerShell, rather obviously. But there's nothing to preclude other languages from generating the intermediate representation. So you run your tool, and it produces a set of documents that contain instances of MOF objects, managed object format objects that are schematized, and they're placed in a staging area. From that staging area, you then deliver that information to each of the Windows nodes. On the Windows node, there is an agent of consistency that interprets that configuration document and calls imperative providers to make things actually happen. The requirements on all the providers are basically the same as pretty much any other configuration management system. They need to be monotonic, always bringing you closer to the desired state. They need to be idempotent, so you can rerun them, which means that they're probably going to be hard to write. But they capture that sort of knowledge, that expression of state, which is critical. This is sort of our agent architecture. I don't know if we can actually read it. Oh, look, the colors are all gone. Oh, well, that might be an improvement. So we're using open protocols to talk to this thing. This is an agent that will run on every Windows machine with the software installed. You can send commands to it using WSMan to a set of WMI objects using the standard protocols to deploy configuration, to start a configuration phase, and so forth. You can retrieve the current configuration. One of the things that we're, from the netconf model, we're recording or we're reusing the idea of maintaining multiple versions of the configuration on the node itself, so it's very easy to return to a previous configuration. We do all of our logging to the Windows event log, which is the standard way in Windows of doing things like this, and everybody gets mad when I say that. We use the task scheduler to schedule the configuration refreshes, obviously, and then a little bit at the bottom that nobody can read, I'm sure, is the poll server. We'll get a little bit to that. So we have two models of deploying configuration. We have a push model where you push out a new configuration to all of the target nodes, and then we have a pull model where the target nodes know where to get configuration from. Not just configuration, in fact, they know how to get software. So our overall design, it is a structural decomposition model where the state of the system is the state of the individual components that are modeled in your document. The desired state can be expressed as any language, producing MOF as kind of a configuration intermediate language, config.il, PowerShell being the obvious one. I think I've talked about the schema stuff already. And then it's delivered in the form of simple text documents, one document per node. Yes. Oh, this is a little bit interesting. So the agent is written in portable C with a portability layer that allows it to potentially run on other systems. Down the road, it would be nice to see what happens, but we're not obviously making any commitments at this time, but we're certainly considering the idea. One of the things that we've done in this area with Windows 8 is we've released an open source SIMOM, a SIM object manager that runs on Linux, and it's available through Open Group, completely open sourced. So standards-based, as I said, DMTF, the DMTF is an industry consortium of Microsoft, IBM, a whole bunch of people, Sun at one point or another. They've defined a common information model for expressing the state of a system, but it's an imperative model. The language for expressing it is MOF, Managed Object Format, which is a variant of IDL, COM, CORBA. History repeats itself. The nice thing about this is that it expresses both schema and instances. And so we looked around. We looked at a lot of things. We considered JSON, for example, but there really isn't a stable schema representation for that. XML has a bunch of problems. The fact that it's a single-rooted document makes composition difficult, getting any kind of common schema, et cetera, et cetera, et cetera. The nice thing about using SIM is it was designed for management. It has a well-specified meta model, and it does both instances and schema. Yes, we releases open source SIMOM. There is Open Pegasus is another existing open source SIMOM, and there are a variety of libraries, client libraries for talking to them. The other protocol that we're using for the pull protocol is OData, which is a RESTful protocol that sits on top of database schema that I think we're trying to turn into a standard, but I'm not entirely sure. So specifying configuration, example source language is PowerShell. The nice thing is that if anybody has recently noticed the addition of iterative constructs to Puppet in the last little bit, this seems to be one of the things that people keep running into, is you either design a whole language from scratch, or you start with a limited language and you add things to it, or you do an embedded DSL that doesn't really understand what's going on. We decided that since we own PowerShell, we would just extend PowerShell, because we've done this before. So you have all the iterative, all of the iterative and composition constructs available in PowerShell to build your configurations. The model for writing providers, the one that we're exposing in this release, so I should say, this is a version 1. We're following sort of the minimum viable product model, so we have just enough features for it to be useful out of the box. So providers today are written, the public providers are written in PowerShell. There is a way to write them in C as SIM v2 providers, but we haven't exposed that yet. And really, extending PowerShell to support this was actually pretty simple. We made one change. We introduced a new keyword configuration, and then we added the ability to understand schematized data. So there's a very limited mechanism for doing DSLs in PowerShell as sort of native language extensions. This allows you to do all the parse time type checking, IntelliSense, and all those other goodness. One of the things that it does do is you express the schema is in the form of MOF classes, and from that, PowerShell reads the MOF classes and synthesizes the necessary keywords to construct instances of the objects. So here's a source language example. Node keyword, so the configuration keyword at the top. Configurations can be parameterized and reused as functions because they're exactly isomorphic to PowerShell functions. You can import modules to import new resource definitions. We have the node keyword for specifying the target node or nodes to deliver the configuration to. And then there's an example of a resource instance which has a type rather than like a Python type constructor. Every resource has a name and then a set of properties. And then you could, for example, run this passing in a list of nodes. And so the schema for that class, this is an example of a MOF schema. Most people don't seem to like it a lot. It's IDL, it's augmented C, so the square brackets, there are a variety of attributes. There are equivalent to enumerated types with the value map. There are metadata for doing description and so forth. A little bit funny in how they specify numbers. You have to explicitly say whether it's assigned or unsigned int. But basically, it's a variation on C, and it supports versioning. So running the script that we looked at a second ago will produce a document that looks like this. So the notation for an instance of a resource is instance of. MOF uses a convention for separating class definitions out by organizations, where it's the name of the organization, underbar, and then the name of the type. So MSFT is something that comes from Microsoft. CIM is something that comes from the standards org. It's very ugly, so we have a friendly name mapping mechanism so that you don't have to type the prefix. From the synthesis, we add a string that identifies the resource uniquely by resource ID. The other thing we do is we want to be able to backtrack to the source, right? If we're generating an error message, we want that error message to correlate to the line in the source file, not some arbitrary piece of MOF code. And so we inject the source information into the object so that the error messages can be correctly aligned. And the final thing we do is we automatically inject a bunch of metadata about who generated it and where it got generated and so on. The format of this stuff is changing a little bit, so this is a little bit out of date. So let's do a bit of a demo now. My lovely VM. So I'm going to create a configuration. Well, it's C1. And I'm going to create a file. Notice I'm getting syntax error checking as I go along. So it says I haven't completed the definition, F1. And now I need to put something in. Because we have IntelliSense, you can see in the editor all of the properties. And this happens automatically. As soon as you import the schema for the resource type, you get IntelliSense support in our editor. So I need a place to put it. Let's do foo. Again, it's doing syntax checking as we go. Just do tab completion. Now, of course, if I mistype one of the properties, I immediately get a syntax error telling me that I've mistyped one of the properties. So this is a big advantage over using the sort of late bound mechanism where you find out later on what went wrong. It helps you create configurations right off the bat. So we'll save that and we'll run it, and ooh, nothing happens because we can't see the bottom of the screen for one thing, because my VM is running off the edge. So the reason nothing happened is that all it's done is it's defined a resource type, a function. To actually run it, right? So now I'm running it. So this time it actually produced something. What it's done is it's created a directory that corresponds to the name of that configuration that contains the configuration file for that target. And so this is the MOF file that's being generated. It's a little boring if you only generate it for one target, so let's add. So what I've done now is I made a slight change to it. I should actually define what my nodes are. This could be a parameter to the script. Right. So the nodes come from this variable. I'm going to create files on each of the target machines in a destination path using content. This content will use string expansion to capture the date when the file is generated. So this is all being resolved at compile time. And then I run it to produce the data, and then I have a start configuration, DSC configuration, which will take the set of configuration files and deliver them to the target nodes. So let's run this one. And you see it's spewing all manner of configuration information. So automatically, as soon as it starts running, you get start of configuration pass, start of a resource, the results of applying the resource, et cetera, et cetera. Automatically, when you author a resource, you can also inject additional messages into this data. This data is all recorded in the event log, so that if you're actually running it in the normal way, which is as a daemon, you can just pull the results from the event log. Oh, and probably nobody noticed this whatsoever, because I didn't, but this directory has mysteriously appeared, and it now contains a file. Bar, or foo, rather, yes. So, and if I look at my other VM, it also contains that directory. So let's look at something a little bit more interesting. Right, so here I have another configuration. I'm calling it temp file. This one takes parameters with all the fancy parameterization that we had before, and it creates a file. So a composite, this is what we call a composite resource type, where it contains code that produces a set of resources that get aggregated into the overall document for that node. And so we're going to create a configuration called main. That is only going to run on the local host because I'm lazy. And so I need so again, from within the file, it picks up that metadata. I got caught. Yeah. I have an old build, so this isn't actually going to work. That's what I get for not using the latest and greatest. But basically, it'll generate, so it will generate 2 instances of the file resource. So enough about that. Okay. So the basic resource model, it's a nominally typed object that is the types have a name with a set of strongly defined properties and no methods. So just a property bag. Resources are idempotent. Reapplication of a resource always takes you back to the same state. And even if it fails, it should never take you further from the final state. So monotonic is important. This was, for you guys, I'm sure this is like, duh. For some of our existing customers, people are like, wow, that's very cool, rather unexpected. So Resources are idempotent, resources are independent. So again, it's a very simple model of consistency. The resources don't know anything about each other. All of the higher layer arrangement is done through the source script. The resources at execution time execute as though they exist in a vacuum. With the singular exception that it supports a requires property, which does ordering. So you can have, for example, if you have a service that requires a particular file to be installed, you can say that the service requires that file resource. Each resource has a unique ID, and then something we've inherited from MOF is this idea of a key property. So because MOF is a management object, management objects are unique resources on a system, and so each object has a key that identifies that property. And so if you have two, for example, the destination path for a file is a key property, you can't specify that twice. And this allows you to do aggregation with limited consistency checks. We do not try and do any complex consistency. Whatever you say is what we will do. We'll just make sure that you didn't say the same thing twice. But because we produce this intermediate machine-readable format, it's entirely possible to do tooling that sits on top of the MOF files and does deeper consistency checks. There was an earlier project at Microsoft called the Dynamic Systems Initiative with system modeling language, which was supposed to be a self-healing, all magic, all singing and dancing kind of thing, and it collapsed under its own complexity, and that was followed by a second project called Lantern that was less all singing and less all dancing, but still tried to do deep consistency checking, and it too collapsed under its own complexity. And thus, at last, we have arrived at the same place that Mark arrived at 20-odd years ago. Keep it simple, stupid. So, since I have a clock, don't have a clock, I have no idea where I am. Okay, so providers, so for every resource type definition expressed as a MOF class, there has to be a provider that implements the schemas, that implements a behavior. The provider has to implement 3 operations: get, set, and test. And our engine will call those in order. Interestingly, one of the things that our model inherits from PowerShell is the notion of what if. Right? So in PowerShell, you can do a command like copy file A over top of file B and say what if, and it will tell you what it'll do, but it won't actually do it. And so that gets plumbed down into our system, and you can say what if when you run a script, and it should tell you the things that it would do, but not actually mutate the state of your system. Get also lets you retrieve the current state of the system. So within the objects, you can define settable properties that are obviously used to mutate configuration, but you can also define read-only properties that give you back more data, a selected set of data from the object. And based on that data, you can do things like best practice analysis. There's a tool from Microsoft called MPCA v2, which is pulls a pile of data from your machine and then does cross-checking to make sure it's configured properly for security or optimal behavior or whatever. And this mechanism will facilitate that. Although really, I figure that you're better off verifying the desired state by looking at the generated data before you deploy it rather than going to the machine and finding out that it's wrong after it's been deployed. But that's just my personal opinion. Providers are idempotent. Oh yes, providers. So one of the things that we've done, and I'll talk a little bit more about that later, is introduce this notion of a pull model. So when you send your script across your MOF file, not all of the providers may be available on the target node. As you evolve the file, you may need different versions of providers. You may need additional providers. And so we have a pull mode where it will actually go to a designated server and download and install the appropriate provider. So it does an analysis of the MOF file, finds all the missing types, goes to the repository, downloads and installs those things. All versioned, of course. I said the providers are currently, only public model is to write in PowerShell. This is what we're shipping out of the box. It's more than the Magic 5 from Puppet, but far less than we need. I really hope somebody writes a chocolatey provider. you'll notice that networking is conspicuously absent at this point. It's something that we're investing a lot of effort in looking at, but really nobody seems to have done a great job of unifying network configuration with system configuration. I mean, netconf is very interesting, but it's often its own little world. People may have an answer that I'm not aware of currently, but it just seems to be the way it is. The script provider is essentially equivalent to the exact provider in Puppet. It's a little bit interesting because we have this notion of $using, where you can proxy a variable from the local environment to the remote environment, and we'll serialize that variable, embed it into the script, and send it across. So it simplifies parameterization of the scripts, and you don't have to do a whole lot of quoting, because I always get it wrong. Implementation details. Let's briefly look at some implementation stuff. So this is an example of, this is not one of the providers that ships. This is a demo provider. But this shows the basic design of the provider. So get target resource is the function that needs to be implemented for getting. The parameters on the function correspond to the properties in the MOF specification. We have a tool that will automatically generate the signature for you from the MOF specification. We're looking at doing the inverse and taking the PowerShell and automatically generating the MOF specification from the function signature, but that would be something separate. And it just basically does the validation on the information. Since this is the getter, it returns a set of properties in this case, because it's just a script. It's actually returning a hash table. So this is PowerShell's hash literal syntax. And here's the set that goes off and builds. So here's the stuff that it's injecting into the progress stream, for example. So you write verbose, and it tells you that the progress is, of the resource as it executes. And then finally down here, it does new VHD, so using the existing commandlets. So it does make it quite easy to take, PowerShell has thousands, 2,000, 3,000 commandlets that cover everything. So it's very easy to take a particular feature and then encapsulate it in a configuration resource. And then the schema, do I have the schema for this one? I don't have the schema up. Okay. Yeah, so here's one of the ones that actually ships out of the box. So it's fully localized, of course, because we're Microsoft and we have to do that. This is the archive provider, so it takes a zip file, downloads it, unpacks it into a particular location. It uses some caching to maintain consistency, so you can say, well, make sure that the file tree actually matches the archive tree, and it does some tricks to try and be performant. Sorry, that's a Microsoft Word performant. I apologize. I can't believe I'm saying it, but I've gotten used to it. So for any module, the providers are encapsulated as modules. You need the implementation of the module. You need the metadata that describes the module, so versioning, et cetera. And then you need the schema. So here's the schema for the archive resource. So those three files constitute a provider. Now let's take a look at the actual implementation of the compiler. A lot of the work that's done to extend PowerShell is actually done in PowerShell itself. Our mechanism for doing the syntax extension is a general purpose mechanism. It's not fully exposed in this release, but ultimately you'll be able to do any sort of data declaration language in PowerShell. Of particular interest is how the MOF gets generated, which is all done as a script. So convert to MOF instance. And I'm pointing this out because if other people want to be able to generate the MOF instances, they should be able to take a look at this code and see what needs to be done. So code as knowledge, I guess. and it's a long script. So that's a little bit about the implementation. Parts of it are in the interpreter itself. All the language extensions are in the interpreter itself. Let's see if I can find the node keyword. So it's talking about how the language binding works. So for each keyword, each synthesized keyword, it has an associated function. So for example, the node keyword that we were using in the scripts earlier corresponds to this particular function in the module. So it's very end user extensible, but we don't tell you how to do it yet, but we will. And back to the slides. So that's a little bit about the implementation. I mentioned earlier that we have a pull model. In this scenario, you have a configuration master where you do all your compiling. You compile your source code, you compile configuration files, and deploy everything to a deployment point. There is a piece of data on each of the nodes, a meta-configuration file on each of the nodes, and that meta-configuration file tells where to pull it from. So you may have one or more pull servers, depending on how you have your network partitioned. It downloads on a scheduled basis. Everything is versioned. When we generate them off, we generate them off. Instance documents with module identification information, module name, module version that was used at compile time, so that at execution time you can do version checking. It talks to the pull server using an OData-based protocol, which is very, very simple. I wanted to have a demo on my Raspberry Pi of how simple it was, but I didn't get around to it. But it's a very, very simple protocol. It's fully documented. With the release of the preview at Build this week, we'll also be releasing the protocol documentation for it. Security is based on certificates. It kind of sucks because security always kind of sucks. But we've done as much as we could to try and make it easy and make it secure by default. Certs are, you can do two-way authentication by installing the certs on the nodes. If you have a cert server, we do encryption. One of the things that we do, which was kind of interesting, is of course you have to embed credentials into your scripts, which is always a pain in the ass, and everybody gets terrified. And so what we do is we actually encrypt the credentials and then install a decryption key on that target node. So the file is still largely in clear text, but all the sensitive information or anything that we declare to be sensitive information will be encrypted. So you can still debug it by reading the text, but you don't get any secrets out of it. This is basically the extent of the protocol. So it's a RESTful protocol, URI based. I think this is missing one of the messages, but it'll all be in the final release documentation. As well as pulling configuration, it pulls modules. It also uploads the status of the system. So if any errors have occurred, then during the poll, it'll upload that information. So basic pull server architecture, you have your compiler, you compile your stuff, you put your stuff on a pull server, and your nodes automatically pull down that metadata. Because it's all files, you can push metadata to a node, you can have it pull metadata, or you can simply copy it onto the VHD before you spark the thing up. And in fact, that's sort of the scenario for the pull server, is that when you build your VHD, you copy the metadata to that machine. That machine uses its ID to figure out what to pull down. And so you can use the same VHD over and over and over again to generate new servers. There's a little orange box at the bottom that says Event Aggregator. That doesn't exist. That's your job, right? So this is where I said we're infrastructure, and so we have a language for generating metadata. We have a representation for that data. We have a way of pushing and pulling that data, and we have a way of applying that data on the nodes. We don't have something that allocates VMs. You can write something that builds a VM, but we don't have a resource allocator. We don't have the monitoring stuff. We just have a piece of infrastructure that can be used to do DevOps in the small or used as part of a larger infrastructure. And that's why we, so interoperation, there's a bunch of ways you can interoperate with what we're doing. One is at the MOF layer. So you could, for example, generate MOF directly. It should be reasonably easy, for example, to write something in Python or Ruby class that produces the corresponding MOF. You can use another intermediate representation, like the intermediate JSON format that Puppet uses could be transcoded into our MOF. We're doing that with some of our other groups. Or you can simply encapsulate the MOF. So you have a PowerShell script that generates the MOF and deploy it directly. A scenario that we've talked to ops code about is the idea of having the pull model interoperate with the existing server capability. So Chef Server has a lot of capabilities built in that would be very useful, and so if they supported this kind of thing directly, that would be awesome. To be clear, before we did the public announcement, we wanted to make sure that our intent would not be misinterpreted. So it's like Microsoft 2.0, now with less evil. And so we actually engaged with CF Engine and Ops Code and with Puppet just to try and, we're not trying to put anybody out of business. We're trying to make your job easier. Configuring, the tools work fantastically on Linux. It's a bit more difficult to do it on Windows. We're trying to do something that fixes that. Logging and reporting, et cetera, et cetera. Interaction, you can use the WSMan API. There is an open source Open WSMan client. There is a Ruby binding for it. It's probably a Puppet bindings for other scripting languages around. I just found the Ruby one. And now we go to our video. And boy, let's see how this works. OK. So this is a video that Adam from Ops Code put together. This is being shown at TechEd in Europe, which is going on right now, I believe. And since we got them to come with us to New Orleans, but we couldn't get them to come with us to Barcelona or Madrid. I wonder why. So let's see if this actually works.
Hello, I'm Adam Edwards from Ops Code, and I'm really happy to be here today to talk about how DSC and Chef enhance Windows as a DevOps platform. If you're not yet familiar with Chef, it's an open source and highly scalable automation system driven by an open source community and Ops Code itself, and it's used by large organizations like Facebook down to the smallest of startups. Today I'm going to show you how we've integrated DSC with Chef to allow Windows administrators to take advantage of DSC capabilities within Chef DevOps workflow and practices. So we're going to show how you can use DSC and Chef together to set up a website. Right now I'm showing you two Chef recipes, and in Chef, recipes are configuration expressed as code in a Ruby-based domain-specific language, or DSL. In each recipe, we've embedded what you may recognize as DSC PowerShell script, and this embedded script is going to help us set up the website. On the one on the right, we have is a script. We have a recipe that will set up the IIS feature in Windows, and you'll probably recognize the embedded DSC code right here. We also, above the DSC code, we have some parameters specified in our DSL that let you control, say, which feature gets enabled with this embedded DSC code. So here, the goal of this recipe is to enable the IIS feature on Windows so that we can have a website. In this recipe over here, we have more embedded DSC code, and we have some other Chef stuff in here. There's a resource called cookbook file, which is a normal part of Chef, and that file is going to refer to the default website's main web page that's embedded in our Chef cookbook. And cookbooks are the unit of packaging for recipes in Chef. Beneath that, once again, we have this DSC configuration script resource, which is going to allow us to embed DSC configuration script in this chef recipe. This one, you can see, will take that file and use the file resource in DSC to put it in the right location for the default website's main web page. So in order for these recipes, this code, to be useful to configure nodes, we need to upload it to a server, to a chef server that stores the cookbooks that contain these recipes. And we'll show how we can use our administration UI and chef to configure these nodes, so that, or to configure these, to configure the nodes so that these recipes will execute on them and thus give us our website. And we're going to try that for the machine we're looking at here. So in order to build our website, we need to have both of these recipes, and we're going to run both of them. Let's just check this system, make sure it doesn't already have a website. So I'm just connecting to the port 80 on the local system, and yeah, there's nothing here. So now let's go switch over to the chef server. This is hosted chef, and we'll see how we can take the chef server, which now contains, we've actually already uploaded the recipes that you were just looking at onto the chef server. This means that nodes that are being managed by chef can now download these recipes and run them on the nodes. In order to make that happen, we've got to set up the particular node we're running on, or any group of nodes, to have these recipes. So I'm going to go take the recipe, the IIS recipe that was on the right, put that in there, and I'm also going to put the website recipe on there. And I'm going to make sure they're in the right order too. Okay, we have to save this. And now the chef server has the correct configuration. We can tell the node to go talk to the chef server and enact the configuration on the system. So we'll run a chef client, which is like an agent for chef, and it talks to the chef server, and it's going to download those recipes onto the system. And typically the chef client is treated like an agent that runs in the background on your system. Here we're running it interactively just so we can watch what it's doing. But it's going to go get these recipes, and after it's gotten all the recipes that it needs, including the IIS recipes that we uploaded, it will then attempt to enact the configuration on the system. So it's going to start executing the DSC configuration script that was embedded in the recipes. And you'll see it's accessing the local configuration manager for DSC. It's, I believe the first thing it has to do is configure the IIS feature. And so that's what it's going to do now. After that happens, then the actual default website file will get placed. And that was that was the other recipe. And now that IIS is configured, I think it's going to go do the website file, and it looks like it says it's all done. It succeeded. So let's go take a look and see if this website is available now. So let me switch to this other tab here. Let's try this again. All right, and there we go. So with DSC, it was pretty easy to just go on ahead and configure a website, get it up and running. There are lots of other resources in DSC. All of those are things that we can take advantage now with Chef because we've done some integration, and because DSC resources behave in a nice idempotent way, just like Chef resources. The integration is really straightforward and reliable, and works well within the DevOps sort of DevOps best practices that we enforce with Chef. So this is really just a fraction of the kinds of things you can do with Chef and DSC together. And I think that as more Windows organizations adopt DevOps, DSC is going to be a huge enabler for them, and for all the vendors who provide DevOps tools like OpsCode. So on behalf of OpsCode and the Chef community, I'd like to thank the PowerShell team for making a contribution that will help the community do even more on Windows. And I'd like to thank all of you here as well for watching us. Thanks.
So that was pretty exciting to be able to get that. We started working with the OpsCode guys so like about a week or two before Tech Ed, so it was very, very rapid integration. You can see some, so really what they're doing right now is they're downloading, they're using their infrastructure to deploy the scripts and just calling it as a scripting language. And that's, it's the most obvious way to do integration, and it actually works pretty well. It did bring up one interesting thing to think about. Windows reboots a lot. You may have noticed this. In particular, after you do things like installing roles and sometimes installing other bits and pieces, it has to reboot. The DSC runtime takes care of that, right? So it knows if a resource indicates that it needs to be rebooted, once the system goes quiescent, it will reboot and then restart and continue to produce, continue on with this configuration. And that's great if DSC is the only thing that's running it. But if it's being run from another application environment, like some of the Azure stuff that we have, or System Center Config Manager, or Chef, or whatever, having your system spontaneously reboot with no notification is bad. It scares people. And so we're going to provide a mechanism where rather than actually having it do the reboot, it will notify that a reboot is required. And that's actually a configurable element in the meta config for the node. You can say whether it should auto reboot or not. And there's actually a bunch of knobs in there that say when it should it run and do automatic updates, should it reboot, and so on and so forth. So that's all documented in our meta configuration class. In terms of supported platforms, so it ships in the box with Windows 8.1 and Server 2012 R2, which are free upgrades to the existing software. We also ship it as part of the Windows Management Framework, which is what we've done with PowerShell in the past, and it goes down level for 2 versions. So, for example, Windows Server 12, Server 2008 R2, Windows 7, and, well, Windows 8, but Windows 8 is going to be upgraded to 8.1, so it's all confusing. But the idea is that we're working with people to identify the platforms where it is most required. Other things that, oh, I forgot to put a slide in for this, but so people ask, because we have these other products, how it integrates with the other products. How does it integrate with things like System Center? How does it integrate with, in particular, we have a product called SCCM, System Center Configuration Manager, which has a component called DCM for Desired Configuration Manager. What DCM actually does is it's an XML schema that does analysis of configuration. So it doesn't actually change the state of the system. It can trigger a script that gets run, but basically it does a bunch of baseline models. So again, it's kind of a best practice analyzer. And it's also primarily targeted at the enterprise rather than at sort of cloud scenarios. It's more focused on enterprise desktop than servers. And then the other thing that people always ask about is group policy, which is, again, another mechanism for distributing policy to a target machine. It pulls it out of AD. It is used primarily on client for doing things like preferences and policies and what you can install and what you can't install. It operates rather differently in that it doesn't enact any changes. The agent downloads and typically puts stuff in the registry, and then the applications pull that information from the registry. So they need to be enabled to be group policy aware. That said, all of these things will coexist for some period of time because there's stuff in Config Manager that we don't do, there's stuff in VMM that we don't do. And so we're working with all the teams. We're actually all part of the same organization now, Windows Server, System Center, to make sure that all of the bits and pieces play together well. So to reiterate, we are bringing integrated desired state configuration management capabilities to Windows in all SKUs, client and server, though we're primarily focusing on server. It is an infrastructure rather than kind of a shrink-wrapped packaged product. It is designed to allow others to leverage the built-in DSC capabilities. The fact that we're going to have the idempotent providers is probably the most important thing for a lot of people. We are very focused on the open standards play. We want to encourage interoperability. Again, this is so it's a little funny to say, Microsoft wants everybody to work together. We usually don't do that, or so people say. So today we have a lot of different products that are all producing very similar resources. So you have a library of Puppet things and a library of CF Engine things. Well, CF Engine is a bit different, as Mark will, I'm sure, attest to. And we have Chef libraries. And so you have all this sort of redundant creation of artifacts. And it would be very nice to have some sort of generic interoperation layer. Because honestly, the value is at the higher layer rather than directly on the node. It's making sure that the configuration is correct, that the node has gotten the correct configuration, and that it's being applied correctly. So that representation, I don't think there's a lot of value in that. I mean, everybody gives away the node part free anyway. So having some kind of synergy between all of the providers so that everything can work together would be very ideal. And of course, we want Windows to work well in that environment. That's the single biggest piece, is that as we scale up, Windows has to be easier to manage. It has to work well in these scenarios. And with that, I will open up for questions. Yes.
Hi. First, thank you for a great presentation. This is really interesting stuff. Have you heard or anything from the other vendors like Puppet and?
We've had some talks with Puppet. OpsCode was the only guys who could put something together quickly enough to demo at TechEd. We're still having ongoing discussions. We're looking to have discussions with everybody we can. There's a TAP program that anybody can join. So, but we wanted to at least talk to some of the most prominent players and let them know what we're doing. Right? It's very important that what we're doing is not misconstrued. We're not trying to embrace, engulf, and extend and engulf, whatever. We are focused on trying to make Windows easy to manage, regardless of the infrastructure. We are Windows, we're an operating system. We need to be easier to manage. There are a lot of fantastic tools out there. We need to work well with those tools. That's our goal.
Great, thank you. Also, is there a roadmap for all of your other products, like Exchange and other server-based products, to have a module so that it's configuring, maybe not something as complicated as Exchange, but something else to merely say, import this module, call it with these parameters, and boom, I have a.
So the roadmap would be after Windows 8.1.
Okay.
That's sort of the extent. I would expect so. Exchange is actually one of the biggest drivers for PowerShell. They were the very first customer. They were the driver for PowerShell remoting. So I will expect that this is something that they would want to work with, and they're in the server group. But we don't have a roadmap for it yet. One of the things, so as I said, we've been working on this for less than a year, and we thought it might be kind of good to actually make sure that it worked before we tried to get other people to jump on it. We've done this co-development across 6 layers thing in the past, and it sucks. And so this time we wanted to have a viable product, be able to get customer input before we started pushing everybody to build on top of it. So, but anybody who's using PowerShell today, I would expect that there would be some kind of additional PowerShell support. We're continuing to do the OMI, the Open Management Infrastructure work, so I would not promise anything in the non-Windows space. But our grand vision is to have a uniform representation of configuration across everything: computers, switches. I mean, we've been working with one of the switch vendors to get OMI into their switch so that they can use WMI or SIM and WS-MAN to manage their switches in a standards way. Yeah, we want to make the entire data center configurable in a model-based mechanism. And boy, are we going to need a lot of help on that one. So,
thank you.
So it looks to me, and correct me if I'm wrong here, but that you've got sort of this 3-layer model where you've got your descriptive language that's translated to MOF that's then applied by the providers on the client machines. Is that on the nodes? Is that
yeah.
And it seems like the provider is the first point at which this becomes specific to the OS.
Right.
So your demo there was using Chef to apply DSC,
Mm-hmm.
but it seems like going the other way might be more might be a more common pattern eventually, where you use a Windows machine to generate the MOF that's then applied by the Windows providers that you have on Windows machines or other providers on Linux machines.
Exactly.
Is that the route you're going, and do you have a roadmap for that you can talk about, or what does the future hold?
So that's where I'd like to go. I don't have a roadmap. I don't get to set the direction. But like I said, we want to be able to have everything interoperate with sort of this. That's what we call the MOF, config.il. It's this intermediate language that is fairly rich, and so it should be usable as a target language for a variety of things. And where things lack, we hope we get input from people. We work a lot with the DMTF around standardization of classes and so forth. If it's worth doing, I'm sure that this is something that we would pursue standardizing. As far as providers, the PowerShell providers can call anything. So in theory, the PowerShell provider could call, for example, a Puppet provider. So the who's on top gets kind of interesting, right? Because you could have Chef call, PowerShell call, Puppet call, Ruby call, everything, and just leverage stuff as much as you can. But it would be nice. But then you have this whole nightmare of log messages that are inconsistent, and you can't really figure out what the hell happened. So again, it would be nice to have some sort of consistent logging. That's something that we're not. We write into the Windows event log, which is specific to Windows, using Windows event tracing format, which is specific to Windows. So we still have work there. What we're trying to do this time, the typical reaction of an admin to Windows event log is, oh, ick. And boy, is it full of useless stuff. So we worked very, very hard with DSC to try and put only stuff that matters in there. Actually, the model that we were looking at, if you've used Visual Studio and Teletrace and their sort of time travel debugging, we want to do that kind of ability to see what happened when. So everything gets logged in journal and tagged from different machines and so on. So you should have a reasonably good understanding of what's going on with your machines.
Thank you. It certainly sounds like MOF is a very exciting component to this.
It's a toe in the water, but it's going to be next. I think Jeffrey, in his talk, Jeffrey Snover, who's a distinguished engineer and overall server architect who started the PowerShell thing ages back, has described this as the end of the beginning. That is, like, we finally have enough stuff in PowerShell to be reasonable. And so everything else after that is we're not playing catch up anymore. Basically, we've been playing catch up. PowerShell brought Windows kicking and screaming into the mid-90s, and so we're trying to kind of catch up with Mark from 20 years ago, which has been an interesting challenge. But yeah, I mean, we know the environment we have to play in, and we're trying to make sure that we do as good a job as possible.
So what's the story between the transitioning from development to operations? When I look at basically DSC, it looks more like an operations tool. So how do we do that translation between what the developers give us to something that runs into production? So
yes, I knew I forgot something. Let's see if I can find what I'm looking for. Comes up in Notepad, yay. But, so one of the things that we're doing is this idea of separating. So the developer would, the separation between environment and structure. And so the developer would configure these DLLs need to be on this machine, this role needs to be installed. They would write those scripts and check them into the source code repository and along with everything else. And then once you get to a deployment environment, we have a mechanism called configuration data. And the idea is a standard way of parameterizing your scripts. And so this is an example from what was demonstrated at TechEd, where you have a collection of attribute value pairs that are passed in, and those are used to parameterize the script. So let's take a look at what that might look like. So here, we'll look at the, yes, we'll look at the end first. So this is how this would be invoked, right? It's passed that you're passing in the environment file. Sorry, here. So this passes in the configuration data to the environment file. And then if you look at the actual environment file, the set of nodes are extracted from that environment file, and then from that set of information, you decide which nodes need to be placed where, et cetera, et cetera. So we do have this idea of a separation between execution and deployment environment and structure. As well, because it's a modular system, people can create modules for each of their associated software components, applications, and so on, and then submit those all into the central source code repository. And when the product gets built, everything gets compiled together and deployed. Using the deployment server, you can put all the modules into a central location, the configuration into a central location, and so on. We do not do the VM allocation, right? So that's something that again, we don't provide. We don't do something like Jenkins. We're not providing a continuous integration, continuous deployment environment, but we're providing tools that should make it possible to hook this stuff into that type of environment. If you saw recently that Visual Studio has acquired a continuous integration tool, and so we'll be working with them to integrate into that. But it should be reasonable to integrate it into any sort of environment. So the other thing about another point about the MOF being machine readable is that you need not necessarily do all of the work on the node. So for example, if you're if your fabric controller understands this thing and it says, oh, I need a VM that has these roles installed and these packages, and I actually happen to have a template where that's already done, then rather than actually doing that work on the node, it can simply allocate an instance of that node. And then when the config script gets there, it goes, oh, I'm done. Good. Cool. Right, so it can be read at various points in the system to do validation, to do allocation, to do things like correct placement of things in the network, and so on. So a lot of extension points.
A couple more questions.
Sure.
Would you have something to handle like the actual configuration, like manipulating the web config files, or just basically to specify environmental specifics?
It's primarily specify environment specifics. Again, it's a separation of structure versus environment. So PowerShell can do all kinds of stuff, right? We don't like the Ruby templating stuff that's being used in Puppet. We don't have anything special for that because we already have a lot of stuff in PowerShell with templating and things like that. So we don't have anything specific there, but you can, for example, write something like in the one example I did, I used $getDate inside the string to actually do some execution, some processing before the data was passed on. It could do a database query. It could do synthesis of a document format by retrieving it from a database. You could read a CSV file, for example, to select your nodes. And so PowerShell has a lot of data processing characteristics or capabilities in there already. It has access to all of .NET. It can emit IL if you really want to. So it has a lot of stuff, right? And that's one of the big advantages, again, that we get out of using an existing fairly rich language, is that we didn't have to do a lot of extra work. You get that with Ruby as well, right? So I think that answers your question.
Second question is, do you know about something that's coming with Visual Studio tooling on that side? Because before they had their own like DSL with like visual modelers to be able to model like your web servers and so on. Is there something coming down that route from that group, or?
We spent a lot of time talking to the Visual Studio team. Their ship schedules are a little different than ours. They've just made this acquisition, so we're still figuring out what's going on. The editor that I was using, the ISE, is actually based on a Visual Studio component, but we at this point have no firm plans or dates for anything. But boy, are we all interested in it.
Okay, thank you.
So again, there are obvious things that we need to do. I cannot commit to any dates or any times or any features, but there are obvious things that we need to do. And as Jeffrey says, it's like a big hint. So, and a lot of it depends on feedback from the community. PowerShell was very heavily driven by the community and by our MVPs. I mean, there's a specific feature where somebody called me up one day and said, we should make it do this. And I said, yeah, that's a good idea. And thus the feature was added. And I don't even remember who called. I can't attribute it to anybody. But we're very community driven. Our MVPs are dedicated, really dedicated, and they eat a lot of sushi. Any more questions? Okay. Well, thank you very much for the opportunity to speak.